So we're still multiplying here, but what we're going to do is we're going to use FOIL to multiply. So it's kind of like distributing, twice. So we know that when we have polynomials, in this form, a binomial times a binomial, we can use FOIL. We can go a times c, and then a times d, and then b times c, and then b times d. Well, we're going to use that same concept. Now, these are actually just real numbers. This is a real number, and this is a real number. So they're just in that form, though, like a binomial. And so, we're going to use that FOILing thing. Okay, so I'm going to try to color coordinate this. 6 times 3, so that would be the first. Then we're going to have to do the outside. So 6 times 4, it's going to be plus because it's a positive 6, positive 4. So 6 times 4 square root 7. Then I've got to do the I. So I'm going to take these two. It's going to be negative. It's going to be 3 times the square root of 7. And then finally I'm going to do the last, which is going to be this one times this one. So it's also going to be negative. And it's going to be 3 times the square root of 7 times 4 times the square root of 7. Okay, so that's how everything lines up for the multiplying. And now we'll simplify. So 18, 6 times 3. Then I have 24 plus 24 square root 7. Then I have minus 9 square root 7. And then finally I'm going to have, now it goes back to how do I multiply those? Well, I take the 3 times the 4, so minus 12. And then I multiply the radical part, 7 times 7, which is 49. And now I have to simplify what I can simplify. So the first thing I notice is this one back here, that I can simplify the square root of 49. So that's going to be minus 12 times the square root of, not times the square root, minus 12 times 7. Okay, the 18 is just 18 right now. But also, we can add these together because they're like terms. 24 square root 7 minus 9 square root 7. They're both apples. What do I get? 15 plus 15 square root 7. Okay, so I have a little more work to do. I have the 18 plus the 15 square root 7. Those are done. And then it's minus, I think it's 84. Okay, sometimes students forget this last step, but that 18 and the minus 4, those can be combined. So we usually put the non-radical part first. So 18 negative 84, what's that? 66? All right. I'm having a pokey day today. I'll double check it. Yes. Okay. Plus 15 square root 7. And then that's going to be the answer because you can't do any more. You can't combine the negative 66 and the 15 square root 7 because one has the square root of the 7 and the other one doesn't. Okay. So, and if you were thinking, oh, I could just add the negative 66 and 15, no, you can't do that. That 15 is attached to the square root of 7. So, we're done. There we go. All right, so here's another one. It looks like it has cubed roots in it, but we just take it one step at a time. So the cubed root of x times the cubed root of x. The cubed root of x times the cubed root of x. And we're going to do the outsides. So it's going to be minus 3 times the cubed root of x. Then we're going to do the insides. It's going to be minus 2 times the cubed root of x. And then finally, we're going to do the last, which is going to be, minus 2 times, well, it's going to be plus 2 times 3, because a negative times a negative is going to be positive. So let's look at it that way. All right, now we have to simplify where we can. This is going to be the cubed root. I was going to keep it color coordinated. The cubed root of x squared. The orange one, that radical isn't going to simplify, so we'll just leave it. The blue one, that one doesn't simplify either. individually. Now in a minute we're going to see, oh, they can combine. And then the last is just going to be plus 6. Okay, so the first one, can I simplify that? No, because I don't have enough x's to get a group out. So that's going to be the cubed root of x squared. Now these two are like radicals, so I can combine them. So I have to think what's negative 3 and negative 2. Negative 5 cubed root x. And then finally I have plus 6. You might be wondering about these first two because they're both cubed roots, but the radicals or the radicands are different, so you can't combine them. So this is done. So in the first one we had like 2 terms in the end. This time we have 3. It just depends on what they give us. So, all right, now we'll have another one. So we're going to take 5 square root 3 times the square root of 3. Then we're going to say plus 5 times the square root of 3 times 2 times the square root of 7. I put parentheses in, but you could have put a dot there. All right, then it's going to be minus the square root of 7 times the square root of 3. And then finally, minus the square root of 7 times 2 times the square root of 7. Okay, now we're going to simplify where we can. So 5 times the square root of 9. Then this next one is going to be 10 plus 10 times the square root of 21. So I'm multiplying the number parts, the parts in front of the radical symbol, and then I'm multiplying the radical parts, okay? And then the next one is going to be minus the square root of 21, because I'm just multiplying the radical parts. And then the last one is going to be minus 2 times the square root of 49. Now, I would just keep writing everything out, because when we take shortcuts, that's a lot of times on these types of problems where, you know, there's a little problem sometimes. Okay, so 5 times 3, because I know what the square root of 9 is. Plus, okay, I see that those two are going to combine because they're like radicals. So I'm going to change it to plus 9 square root 21. Now you might be thinking about 21, oh, could that simplify? No, because it's just 7 times 3, so you don't have a pair that can come out. So it's going to stay the square root of 21. And then the last one, though, I have minus 2 times 7, because square root of 49 I know. Okay, so I get 15 here plus 9 square root 21, and then I have a minus 14 on that back part there, 2 times 7. Okay, 15 and minus 14, those two can combine. So 15 minus 14 is 1 plus 9 square root 21. Now, you might have a question about the 1. Do you have to put the 1? And you do. And the reason for that is because it is 1 plus something. It's not 1 times something. So when it's multiplication, a lot of times we don't write the 1. But this time, the 1 is its own term. So we have to write it. Okay, that was a long video.